Hello again, class. Today, the purpose of this video is to help you use slope to determine if lines are parallel, perpendicular, or neither of these. So I'd like you to take out your notes from yesterday. You should have glued these, I believe, on page 72. And what we did yesterday is we learned how to compute the slope of 2 points. And we did not have to draw the line. So we have here some examples. Let me erase that and just kind of show one more time how we did that. Because slope is rise over run, this is a quick review from yesterday. When given 2 points, what you're going to need to do is to go ahead and start with, let's do example 2 here. We're going to start on the y coordinate of 1 point, and it doesn't really matter which one. And then you're going to subtract the other y coordinate of the other point. So the slope in this case is going to be -6. Now, because 3 has a negative next to it, we need to put another negative. It's always minus, but when there's a negative with the number, you end up with an additional negative there so that you account for that negative. Now, on the bottom, you're going to go ahead and do the subtraction of the x's. Make sure that if you started on the point on the left, you also start with the x coordinate on that same point. So in this case, it would be 8 minus 5. On the top, that's 2 negatives become a positive, giving you -3 over 3, which of course reduces to -1. And so that's what we learned yesterday. Today, we're going to take it a bit further. We're going to use that idea of slope to compute, to determine if lines are parallel, perpendicular. So in your notes, you should already know, you should have this already there in your notes. We haven't really written anything on them, so we're going to write on it today. In your notes, you should be able to see that this set of parallel lines here. And one of the things that you should know about parallel lines is that parallel lines never intersect. So that's kind of the first point we want to make about parallel lines. They never intersect. And we actually talked about this before in the previous unit on geometry, where we had parallel lines cut by a transversal. But in this case, these lines don't have a transversal. They simply are 2 lines that never intersect. And what we're going to do is we're going to just kind of play around with them and compare their slopes to see what happens. I'm going to call this line L, and I'm going to call this line M. In line L, I'm going to just pick any 2 points that allow me to find the slope. I think probably the easiest point is this one here, and then the y-intercept. So I'm using the x and the y-intercept to do this, but you could have easily picked any other 2 points that are easily identified. So any of the ones that I've sort of pointed out would have worked, but I'm going to just use these 2 right here. And I'm going to use the idea of rise over run. So how many do I have to rise to get to the next point? It's going to be, see, 1, 2. So that's going to be a rise of 2 and a run of 1. So rise 2, run 1. That means the slope of line L, I'm going to put it over here, the slope of line L is going to be 2 over 1. 2 over 1. Now I probably shouldn't have used M to label the second line, mostly because M means slope. So instead of M, let's just use P, line P. In fact, I'll make that in a whole different color so we can tell, line P. And the only reason I don't want to use M is because I'm already using M for slope. Alright, now I'm going to pick 2 points here. It doesn't really matter which ones you pick. I'm going to pick again the y-intercept and the x-intercept, but again, you could pick any point that you can easily identify. And what we're going to do now is go ahead and find the rise over the run. So we rise 1, 2. So rise 2 and run 1. So the slope of line P is going to be 2 over 1. And you guessed it. Something that you should definitely notice about this is that the slope of line L and the slope of line P are the same. That is going to be true of any 2 parallel lines. Not only do they never intersect, but their slopes are equal. And you want to write this down in your notes. Their slopes are equal. So that's important about parallel lines, okay? they never intersect, and a characteristic is that their slopes are always equal. So let's move on to perpendicular lines. Perpendicular lines intersect clearly. You can see here they have an intersection point. Let me use a different color for that. Perpendicular lines are going to intersect, but not only do they intersect, when they intersect, they form a right angle or a 90-degree angle. So perpendicular lines intersect, forming 90-degree angles. Okay, and that's important. So we're going to again analyze their slopes. We'll just call this line Q, and then I'll call this other line W. Okay, so for line Q, we're going to pick 2 points to find their slope. This is a good one right here, and probably this one I had identified already. And I just want to find the slope of Q here. So I'm going to do rise. Since I'm going down, that's going to be negative. 1, 2, 3. Let me erase, make sure that that point is a good one. You know what? On hindsight, that's not a good point. It's not right on the coordinate. You see, it's not. It intersects line W, but it's not right. Is it? No, it is. It is. Line W is not, but line Q is. Sorry. So that's a good point to pick. If that one's kind of hard to see, you've got other ones that you can pick as well. Okay, I'm just going to use those two. So I'm going to go down 1, 2, 3. So that's a -3. And I'm going to run 2. So that means the slope is rise over run, -3 over 2 for line Q. All right, let's do W. If you look at W, see, let's pick this one right here, this one right here. If we do the rise and the run, that's going to be up 1, 2. That's a rise of 2 and a run of 1, 2, 3. So the slope of W is going to be rise 2, run 3. Now, these slopes are not the same, okay? But there is a relationship between them. First of all, one's negative and one's positive. So that means that perpendicular lines are going to have opposite slopes, one positive, one negative. It also, if you notice, this is 3 over 2. It flips, it becomes 2 over 3. That flipping is called a reciprocal. Reciprocal. Okay, reciprocal. When you flip a fraction, it's a reciprocal. So what that means for us is that parallel lines, we already know, have equal slopes. The slopes of perpendicular lines are going to be opposite, which mean one positive, one negative. So opposite, reciprocal. Opposite reciprocals. Opposite meaning one positive, one negative. Reciprocal meaning flipped. And those are the two things that you have to remember for the next part of the notes. Parallel lines, same slope. Perpendicular lines, opposite, reciprocal. Okay, so now this is a typical problem that you're going to see. You are going to be asked to determine if the lines that pass through the given points are parallel, perpendicular, or neither. So in this example A, we have two lines. We have line 1 goes through these 2 points. Line 2 passes through these 2 points. So these are 2 separate lines passing through those coordinates that are shown. And your job is to determine if they're parallel, perpendicular, or neither. So we're not going to graph them. That takes too long. Instead, what we're going to do is we're going to compare their slopes. We're going to find the slope of line 1, and we're going to find the slope of line 2, and if we get the same slope, we know they are parallel. If we get opposite reciprocals, then they're perpendicular. And if we don't get any of those situations, then we pick neither, because that means they're just 2 lines, but they're not special. They're not parallel, nor are they perpendicular. So let's get started with line 1. I'm going to find the slope the way we learned yesterday. So I'm going to set up my slope. It's going to be 0 minus 3 on the top. Remember, y's go on top, x's go on bottom. On the bottom, I'm going to use -6 minus a -2. There's an extra negative there, so I got to make sure I account for it. On the top, I get -3. And you got to be really careful with your positives and negatives. On the bottom, I get -4. And I do have 2 negatives, which become a positive when you're dividing. So that's 3 over 4. Okay, that's the slope of the first line. The slope of the second line, I'm going to find now, it's going to be 4, so this is a slope, 4 minus 7 over 5 minus 9. So on the top I get negative 3 because 7 is bigger than 4. And on the bottom I get negative 4 because 9 is bigger than 5. And I end up with negative and a negative, which become positive 3/4. And so as we discussed earlier, if you get the same slope, which we do, 3/4 and 3/4, your determination then is that these two lines are parallel because they have the same slope. Okay? On a test situation, I'm going to give you a point for each slope and a point for the correct conclusion. So make sure that you show all your work, okay? All right, you have example B. What I want you to do is go ahead and pause the video and work it out. Work the slope of line 1, work the slope of line 2, and determine if they are parallel, perpendicular, or neither. And then push play, and I'm going to go ahead and work it out myself, and you can compare with me, okay? Okay, so the result that we got here is not exactly what we would say the same. This one came out to negative 5/5, and I have my setup here in case you want to pause the video and check it out. And my other one came out to positive 5/3. So I have negative 5/3 and positive 5/3. Well, they are opposite slopes, so I'm tempted to say they're perpendicular. They're definitely not parallel. They would not be parallel because they're not the same. They would have to be exactly the same to be parallel. But in order to be perpendicular, we need two things to be true. We need them to be opposites, which they are. One's negative, one's positive. But we also need them to be reciprocals. In other words, one needs to be flipped from the other. And here I see a 5/3, and here I see a 5/3. So it's tempting to say perpendicular because of the negative and the positive, but that's not the case. I would need for this one to be a 3/5 in order for this to be perpendicular, and it's not. So in this case, although it seems like it should be perpendicular, it is not. Definitely not parallel. So I would answer neither. Okay, neither. Neither means they are not parallel, they are not perpendicular. They're two lines, they intersect, but they're not special. So what you're going to do now is go ahead and take out a clean piece of paper, and you're going to divide that paper into 8 sections just like you did before. And you're going to go ahead and use that space to compute the slopes of the lines that I'm leaving as an assignment, and determine if they're parallel, perpendicular, or neither. And the assignment has already been uploaded to Elluminate, so you just now need to go to Elluminate and get started. I encourage you at this time when you do this to go ahead and go finish all of the other work from the past 2 days, because those assignments are going to count in your grade, and they are big assignments, 20 points each. I hope you're doing well. Tomorrow you'll have a review of everything you've learned over the last 3 days, and I should see you back again on Friday. Let me know if you have any questions via email. jvaldez@yumaunion.org, and I'll write that down for you in case you want to know. That would be, if you have any questions, jvaldez@yumaunion.org. Thank you so much.